video, we are going to complete our bookshelf. We're going to continue where we left off from part 1 by creating a backing for the bookshelf. We will look at duplication, UVs, and materials. And in this video, we're going to cover pretty much the same processes so we can actually move just a little bit quicker. All right, so we need to create a plank and we need to add it to the back. So we know how to create the primitives. We know how to work with primitive 3D. And we can use that same process of a basis and transfer node to place the primitive in the location that we want. So let's get started here by just creating a new basis. So I am going to create a basis node, and I'm going to take the result of our merge, which is what we see here. Now let's go ahead and just make a comment on this. So the result of this merge is going to be our bookshelf with no back. Okay, so there's no back to that bookshelf, and we can take this result and plug it into the basis. And let's take a look at that basis. We can see here that it's now aligning itself on the origin, the Y max, or the top of the bookshelf. I'll shift left click the merge node so we can visualize this in the wireframe. And if we want to switch the orientation or the origin of this basis, we can just use the drop down. In this case, we want to place it on the back of the bookshelf. So we're going to use Z min. And there we go. Now we've set up our custom working plane. Now we can take a primitive 3D or another plank that we have, and we can basically transfer it to this new custom coordinate system. All right, so shift, left click in an empty area of the graph just to get rid of that wireframe. Now I need a plank. I already have a plank, which is going to be the side plank. This is the side plank that we created in part 1. And this is what this primitive 3D looks like. So it's already sitting at the origin for us. I'm just going to select this node, copy, and paste it, and just move it over into this area where we're going to be doing our work. Let's right-click, add a comment, and this is going to be the back plank. So in order to take this primitive and place it onto the basis, we need to use our transfer node. So we'll create our transfer. Let's take the primitive as the input and the basis as the target. Double-click the transfer, and now you can see that that plank is now applied or placed onto that custom coordinate system that we just created. So let's more clearly visualize this by adding a new merge node. So we're going to do our merge. And what we want to do is we want to merge the bookshelf with no backing. And we want to merge the result of the transfer, which is this plank. And we'll double click the merge. And here we go. You can see that we now have a plank that is placed on the back of our bookshelf. And you'll notice that this plank has already adjusted itself to the height of the bookshelf. And that's because we simply copied this primitive. And if we take a look here at the primitive, I already used the measure bounding box from the array duplication. That's the node that's creating our planks. So it gives us this Y height. And we already measured that, and we took that information from the vector 3 to float, and we plugged that into the width. So now, just by simply copy and pasting that, we've already done the work. That's great. So now that this is in place, what we're going to need to do is actually adjust our depth property. And so if we look at the plank itself, because of the orientation of the plank, we're going to be adjusting the depth. So if we look at our plank and we look at this orientation, this is the depth. And our width is actually the height. Again, just because we've taken this primitive and we've rotated it and placed it here on the back. So if I come over to the primitive and I have data coming into the depth, this I'm going to change. So let's alt left click the input pin to get rid of that information. It selects the node. So let's go back, double click on the merge. I'll select the primitive once again. I now have my slider control. So here again, just to show you, this is what we're going to do. So we need to adjust this depth. And we need to basically have the depth be driven by the width of the actual bookshelf. So in order to do that, we're going to do some measuring again. Now we've already seen this work in part 1. So here's what we're going to do. We're going to grab a measure bounding box. I'm going to measure the bounding box in this case from the bookshelf with no backing. So we'll just grab that in the geometry to measure. We have our minimum and maximum output as a translation, which is a float 3. So let's just break out a pen here, and we're going to use this vector 3 to float. So now we have some information here for the X, Y, and the Z. Now we know that our X, Y, and Z basically translates to our width, height, and depth. So like I said, we want to take the depth of the back plank and we want to drive that by the width of the bookshelf. Okay, so the width of the bookshelf is going to be the X value. So let's go ahead and just move these nodes around just so this visually makes sense. So like I said, the X represents the width of the bookshelf as measured by our bounding box, and we're going to plug that into the depth. So we'll go ahead and do that, and you can see that, well, that plank, it did expand, it did get a little larger, but it's not quite what we would have expected. And that comes down to the way that this measure bounding box is working on this X value. So let's do this. Let me drop this over into wireframe. And if we zoom in and take a look, here we have our grid and our axis, right? And we have our X axis, and then we have our origin point for our grid. So if you look at this, you're going to have like a 0, 0, and then we're going to move from 0 to 1 to 2 positive, and then we're going to go from 0 to -1 to -2, and so on. Now, the measure bounding box is really just taking from the origin to one side. So that's why we're basically only getting half of what the bookshelf is going to be when we measure this bounding box. And the reason why that is because the bookshelf is centered perfectly at the origin point of our grid. So we're only getting half of what we need. It's no problem, but it's just good to know that that's how that system is working. All right, so easy fix though. What we're going to do is we already have the width and we know it's exactly half, and it will always be half because our bookshelf is centered right here on our grid. So what we can do is just use our binary operation on float. We're going to take that width value and we're just simply going to multiply it by a value of 2. So no matter what the width, it's always going to be correct. So we multiply that by a value of 2. Let me move around here towards the back. And now if we take this new result and we plug that into our depth, now you can see that the back covers the width of the bookshelf completely, just as we need it to. So things are coming along pretty well, but as it usually goes, we have yet another issue. If we zoom in really close, I can see that the back plank is overlapping. Let's jump into our wireframe mode so you can see it. It's the same problem that we had before. We just need to offset this back plank by half of the height. We know how to fix it. It's just a little bit of extra work that we got to do. And so I know that we can do that, or we can add that transform right after our transfer. So here's what we need to do. Just again, we need to create a transform again. We'll plug in the source. Let's go ahead and plug this into the merge. Now, as you can see here, I'll select the transform. And as I said, if we start to move this on the Z axis, we can offset. And that's what we need to do. And we're actually going to have to offset this in the negative direction, just like you see I'm doing here manually. However, like I said, we want to make sure we do this procedurally. So we know that we have the height of all the way back at the root of our graph. So here's our height. Several times now, we have used different nodes to compute that half height like this. And we could just borrow out some of these connections, but just to reinforce the process, let's just do it again from scratch. So again, we're going to do a binary operation on float. We need to grab our height. We'll plug that in. And we are going to do a multiplication by 0.5, which is going to give us half. Now we need to move in the negative direction. So just to save time, I'm going to go ahead and just type this as negative 0.5. All right, so now that I get that, let's just move this node all the way over to here. And I'll go ahead and comment this. Let's just add a comment and we'll say half height, just so we know what that's doing. On our transform, we need to expose our translation. So I'll click the second pin. So now I have an input pin. We have our data, but we need to convert it to float 3. So here is where I will drag out a pin and I'm going to say float to vector 3. So float to vector 3. And you can see here that I already have the connection set to the Z translation. That's what I want to have. So again, these floats represent X, Y, and Z. Just make sure that you have that half height information going into the Z. All right, so now that we have that in place, let's take the result of that vector 3 translation and plug it into the transform. And now we have the offset. So if we take a look at our bookshelf, we now have a completed case. We have the shelves, we have the sides, we have the back, we have everything in place. You can also, at any time, just come over to your render and just pop this into iRay, and this gives you a nice little, ray trace version, so you can really start to see what your geometry looks like. The bevels are looking really nice as they pick up some of that specular highlight and so on. And like I said, you can just pop this in and just get an idea of how things are going to look. Let me drop that back to my OpenGL, and let's just start to do a little testing on the system here. So like I said, we got a couple things that we're going to work with. For example, the shelf amount. Let's change this. Let's set this down here to like a value of, say, 2. So we have a bottom and the top that's going to be 2. And it looks like everything's lining up as I would expect. So now we'll come in and start to increase this value. And as we do that, we'll go past 6, we'll go to 7 or 8. Got a pretty tall bookshelf here. And again, we're just checking the system. Everything's lining up as it should. So I'll go ahead and drop this back to like maybe a default value of, say, 5. So some of the other properties that we will probably want to tweak is this width. So again, if we come in and take a look at the width, we can maybe turn that bookshelf into like maybe a shelf for maybe shoes or something like that. And again, you can see everything is still lining up and it's all working as it should. I'm going to go ahead and set that back to my default 94. We also have our depth. So if I want to maybe make this a little bit of a deeper shelf, maybe something more like, I don't know, like a filing cabinet or something, we can do that, or we could make this even less, and so on. Again, the main point is we're testing things out and everything's lining up and working as it should. Let me just undo that and get that back to that 30 depth. So now that I have my bookshelf, I'd like to create some copies of the entire bookshelf, and I can do that by using array duplication. So let's hit the space bar, let's do a search for array, and we have array duplication. Now what I'm going to do is take the result of my merge and plug this into the scene as well as the bounding box, and then double click the array duplication, and this is what we get. So something's happening. We are getting some duplication, but this is not what we expect. And if we take a look, you can see that under the bounding box properties, we have duplications in the X, Y, and Z all set to 2. So we could come in and say, oh, okay, let's adjust the Z to 1, let's adjust the Y to 1, and the X is 2, but it's still not really duplicating correctly here. There's something strange is going on. And with the array duplication node selected, if I come over to my scene browser in my 3D view, you can see here that we have these 2 elements. One thing I will point out is that this plank back, I did go ahead and just rename that. So if we select that primitive 3D, you can see in the output tree path, I did name that to plank back. Okay, so like I said, the array duplication, if we're looking at the scene browser from this node, we have these 2 elements just showing up here. Let's look at the merge and see what we get. So under the merge node, we do see all of these elements, but they're basically separated. So we have like plank 5, which is kind of like one element piece, which is the 5 shelves. We have the back, we have a side, and then we have our other side over here. However, these are all individual pieces that are being sent over to the array duplication node. However, what we really want to do is we'd really like to treat all of these pieces as one element or one bookshelf that we can then duplicate. Well, there's an easy way to kind of set this up in the merge node, and that's to use this group naming convention. So by default, it's set to blank, so everything being plugged in or fed in through the merge node is all a bunch of individual pieces. So what I'm going to do is just come over here and just give this a name. It could be anything. I'll call it bookshelf. Now, as soon as I hit enter, if you watch, you'll see that we get a new grouping here in the scene browser. So we'll hit enter, and now we have our bookshelf, which is one element, and it's made up of the individual pieces that we're going to be working with. Now, this bookshelf grouped element is now what I can feed over to the array duplication. So if we take a look now, let's double click array duplication. You can see that indeed it is now duplicating that entire shelf with a value of 2 on the X axis. As you recall, we set the Y and the Z to 1. So now if I come over here and I start to increase the duplications, I can just quickly duplicate the entire bookshelf to make multiple copies, which is pretty cool. All right, so one other thing that we have going on here is you can see that it is duplicating, but it's based off this origin point. There is a setting here, which is very handy, called center. It's set to false. If we set this to true, it's then just going to center this array duplication. So now as I come over here to the duplication slider and start to increase this, you can see that the duplications are now happening from that center origin point, which is precisely what I would want for a procedural asset like this. So real easy just to set that to true. All right, so now that we have that, We're definitely going to want to have this as a user control. So I'll come over here to this button to copy this to a new node. So we have this node. Let's right click, add a comment. And this is going to just be the bookshelf duplications. Okay, so now with this guy, we can come in and just make adjustments here. So also, just to double check everything, we have our duplication. If we come back to say something earlier in the graph, like the shelf amount, we can now adjust this, and you can see that that shelf amount is also feeding over to the array duplication. So everything seems to be working. Again, if we check something like, say, our width, we can adjust the width as well. All right, I'm going to go ahead and set this back to that default 94. And then I'll come over here to my duplication, and I'm just going to set that to say something like 3. So now we're going to take a look at working with UVs and materials. So to start, I'm just going to open a substance material here in my Explorer. And so here I have a substance material file, and this graph is automatically applied to the 3D view. Because we've been working with the primitive 3D node, UVs are automatically being generated and updated as we work. What's really cool about working with these 3D models here in Designer is that we can work on the 3D model as well as the procedural material at the same time. So for example, I have my substance material graph. I'm going to go ahead and just pin this, and then let's just take the graph and just dock it down here towards the bottom. Now I'm going to come back to my substance model. Let me just double click the bookshelf to open up its graph. So now I have the 3D model graph here. Let's left click and drag this over here to the top left. So now what we have, which is a pretty interesting setup, is we have our substance material graph here and our 3D model graph here on the top. So our 3D view and our 2D view. And we can work on the material that's applied to the 3D model or update the 3D model all within the same workspace. So one thing I want to point out, if we take a look at the material that's applied, you can see that it's very uniform on the shelves. So let's make an adjustment. I'm going to come over here to where I have the array duplication. And right now we're looking at everything as one single element that we're then duplicating here. So what I need to do first is I need to expand the instances so that I can basically manipulate the UVs for these individual elements that make up our shelf. So here, if I hit the space bar and I do a search for expand, you can see there's a node called expand group instances. I want to use this guy. So let's take a look at our scene browser and see what we get so far. So right now you can see that we have our bookshelf. And if we go ahead and take the array duplication and plug that into the expand group instances node and then double click, you can see we now have access to all the individual elements that we have here in our scene that's making up everything that we see or part of our 3D model. Okay, so now that we have that data, we can then hit our space bar. Let's do a search for UV, and we have several nodes for working with UV coordinates. The one that I want to work with now is called jitter UV. So we'll just use this to randomize the UV coordinates for all the different elements. We'll plug this in. Let's double click to access or view the results of that jitter UV. And then in the U position for minimum, I'm going to set this to a value of -1. Then we'll go to the maximum and set that to 1. You can see we're already starting to get some different results. Let's go to the V coordinate and set this to -1 and the max value to 1. So now we get a non-uniform result. You can see that the wood pattern's no longer lining up perfectly, and we just get something that's a lot more interesting. So something else I'm noticing here, if I look at the planks for the back of the shelf, I feel like the scale is off. So we could adjust that as well. So let's zoom out on our 3D model graph here, and we'll come over to this section. So let's see, we have this merge node, which is giving me the shelf here, and then we have our merge, which is the complete bookshelf. So let's just go ahead and make a few comments. We'll right click here, add a comment. I'll call this bookshelf back. So we have one that has no back and one that has a back. And then these nodes here in the middle of this are going to make up the back. So we could just select these nodes. Let me just move this around, select these nodes, and then I'm going to set up a quick frame here. And we'll just call this back plank. Okay. So like I said, we now want to make some UV adjustments to that back plank. Let's come back over here to our UV jitter so we can see the result of everything. And then here, right after this transform, what I'm going to do is, again, search for UV. And we have a UV transform node. This is what I'm going to use. So let's hook this up into the graph. And then on the UV transform, we have a scaling. So I could just come in here and just set this to like a 2 by 2. We've essentially just scaled the UVs, which gives us a tiled result for the texture. And this is looking a lot better. And as I was saying, we can always just jump down here to our material graph. Let me just double click an empty area here in the graph. And let's take a look at some of the parameters we have. So maybe here for the wood color, I'm just going to go in and just maybe slightly change this color here. And you can see that it's just going to go ahead and just start to update automatically. Again, that's quite cool that we can work with a procedural material and a procedural model all within the same workspace. So at this stage, we have a single substance material that's been applied to the entire model. But we can also create different materials within our model as well. So let's say, for example, just for demo's sake, that I want to take the shelves and just give them a separate material. Or there's a really quick way we can do that. So let's come over here to where we have basically our plank, which is right here, our shelf plank. And this is right here after the array duplication. So I think what I'll do is just apply a material right after the shelf plank, which is going to, like I said, just for every single shelf, just give that a different material. So what I can do, we'll hit the space bar. And if I do a search for material, you can see that we have a set and tag material node. So let's grab the set material. And we're going to give this a piece of geometry as the geometry input. And so now we need to input a material. This is where our tag is going to come in. So again, if we type in material, this is our tag material. And let's plug this guy into here. Now, for the tag material, we can give this a color or a name, more importantly. So I'm just going to call this shelves. This is going to be now my shelves material. So now let's just take this set material node and just plug that right into the transform, basically to integrate it here into my node network. And so now you can see here in my 3D view that, well, we have a new material just by using the set and tag material. So a quick way to apply a material to this, let me just open up another substance procedural material. So here you can see I've opened up another substance material. I forgot to pin my model graph, so it was kind of overwritten here. No problem. We'll just double click bookshelf again. And then, like I said, I can always pin this so that it doesn't disappear when I open another graph. And then I can just come over to this sandblasted steel material graph. If I right click, I have an option to view outputs in 3D view. So we're going to choose this option. You can see that now it gives me that shelves tag that we just created. So if I choose this, I'm now applying that material to the material tag that was set right here in my model graph. And so here's what we get. Let me come over to my renderer and set this to iRay and just take a look at the results. So this is that procedural model that we created. We've adjusted the UVs, and we've also applied another material to the shelving. Now we're going to talk about exposing parameters. I've gone ahead and removed the substance materials from my Explorer. I was only using those to check the UVs. Everything is working, so I no longer really need those materials displaying here in Designer. I've also set a frame here for the set material that we created for our shelving. Okay, let's get to talking about exposing parameters. Here you can see that we have a few nodes for our width, height, and depth. And if I want to expose a parameter, all I need to do is select a node, right-click, and choose Expose. Now, this is a little bit different than working in a substance material graph. So for example, if I select the primitive 3D, you'll notice that I don't have an option to expose this specific parameter. The parameter needs to be driven by a node specifically in order to expose it, just as we've done here with the width. So now that we have a node that's driving the width parameter, I can select the node, right-click, and choose Expose. So similar to a substance material graph, you can see here that I have an identifier that I can set. I have some ranges. I can set a group and a display name. So here I'm going to call this shelf width. And now I can set my soft and hard range. So for the soft range, I'll just enable this, and I'm just going to set a minimum value, I guess, of say 5, and I'll leave the max at 94. And the slider that you see here is allowing me to set that default value, which in my case is going to be 94. Now I can also set a hard range. This is going to be a minimum and maximum value that the user is not able to go beyond. So in my case here, I am going to go ahead and keep that capped at 5. And for the maximum, I think I will set this to 100. Okay, so now we've exposed this parameter. And if I just double click an empty area in the graph, I'm now at the root level of my graph. You can see I have my attributes, annotations, and then here I have my graph inputs, along with the parameter, my shelf width that I have exposed. And you'll notice it's set to 94 as default. Now, to show you that hard range value, if let's say I go into here and I type in something like 125 and I hit enter, you can see that it just locks to that 100. It's not going to let me go beyond that hard range value that I set. So in my case here, I'm just going to go ahead and set that back to 94. And that's all we need to do to expose a graph. So now I'm just going to run through the exact same process. You can see that I'm going to just expose this shelf amount. And then I'm also going to just jump over to towards the end of the graph here and just expose the value for the bookshelf duplication. And so now on my graph, you can see I have my graph inputs and I have the three parameters that I have exposed.